In this video, I'm going to run through the notes for Unit 2, Part 1, Lesson 1 of our college algebra class. This lesson is going to cover function notation, and we'll also talk a little bit about the domain and range of functions. This first graph on the top left is pretty typical, and it's used to ask questions about function notation and to make sure that you're completely comfortable with function notation and how to interpret a graph. And of course, this blue line does represent the function f of x. And sometimes you'll see in textbooks this little phrase written here, y equals f of x, because our y-axis represents the component results, or the results of each function after it's been evaluated at a particular x value. So a question like A is asking us to find f of 0 and f of 6. Well, f of 0 simply says, give us the function result when x is equal to 0. So here on our x-axis, when x is 0, if we look upward, we see a result right here connected to the graph. And the result, or the y value, when x is 0, is 3. Similarly, the function evaluated at -6, well, -6 on the x-axis is over here. If we look to the graph to find our solution, the y component associated with an x value of -6 is -3. Go ahead and try part B on your own. And the results are as follows. F of 6 is equal to 0, f of 11 is equal to 1. Now, this particular graph is helpful because the coordinates themselves are provided and it's very easy to interpret. If we were to answer these questions without such a precise graph, we would have to do our best to estimate the solutions. Now I can see that this is going to get kind of tight here with the answers, so I'm actually going to move these below the problem set and start recording them down below here. Okay, I think that looks a little bit better. Now question C and D, is f of 3 positive or negative? Is f of -4 positive or negative? Well, let's again keep in mind that this notation, f of 3 and f of 4, represents y coordinates. And y coordinates, of course, are positive above the x-axis and they're negative below the x-axis. So what do you think? Is f of 3 positive or negative? And is f of -4 positive or negative? Well, here again, we're talking about y values, and since the y value associated when x is 3 is above the x-axis, we would say that it is positive. And an easy way to say positive is to show that it's greater than 0. For f of -4, we don't have a coordinate to look at, but we can see that the result, the y component, when x is -4, the y component is below the x-axis, so we can say that f of -4 is negative, or less than 0. For E and F, we're asked to find what values of x. Is f of x equal to 0? So when is the y value 0? What x values make the y value equal to 0? And what x values make the y values positive or greater than 0? Well, for question E, there are 3 spots where the function is equal to 0, and that's located when the x value is -3, +6, and +10. And a nice way to create a list of numbers is to separate them by commas and group them with these braces here. So if we're looking at the graph, again, with an x value of 3, +6, and +10, those are the locations where the y values are exactly 0. Now when we're asking ourselves when is the function positive or greater than 0, well, all x values along this little blue curve and even this small section over here, all of those x values are associated with y values that are positive. So when we report our answers, we want to say all x values between -3 and +6, and again from 10 to 11. Now we're not going to include the number -3 or the number 6 because the y value is neither positive nor negative. The y value is 0. The function is equal to 0. So we've got to be a little bit more careful with the way we record this answer. So we can say an answer would look something like this. -3 is less than x, which is less than 6, and also 10 is less than x, which is less than or equal to 11. We did include 11 on the right-hand group because at the position where x is 11, the function is positive. It is greater than 0. These answers are a form of what we would call set notation. It's not completely accurate for set notation, but it's pretty close, where we use the inequality symbols. Another option, which our calculus class tends to use, is what we call interval notation. And we're going to spend some time talking about that in this lesson as well. But the interval notation would look something like this. We would say that x is an element, so we have this kind of curvy looking E for element. X must be an element of the set of numbers from -3 to 6, non-inclusive, and the set of numbers from 10 to 11, where 11 is included. Now I hesitated a little bit with this symbol here. This is meant to look like an upside down U. And I did say the word and, but to be precise and correct, this symbol actually means the word or, and that would be appropriate here. And we'll leave that to our conversation in class to go over the nuances of and versus or. For question G and H, we're being asked about the domain and range of the function f. And let's keep in mind that domain represents the possible x values associated with the graph or the function, and the range is associated with our y values. What we're trying to do is we're trying to create a list or a group of possible numbers that could be represented as x values in this graph. And one way that we can think of that is considering all of the x values from the leftmost x position to the rightmost x position. And if all coordinates on this graph can be included in that group of numbers, then we would say that the domain of x exists, the domain of f exists from, in this case, -3 all the way up to +11. And it includes an x value of -6, and it includes an x value of +11. So if I were to report the domain using interval notation, I would say something like this. The domain of the function are all x values that are an element of the numbers, the set of numbers from -6 to +11 inclusive. Now the range is quite similar. This time we're talking about y values, and we're essentially looking at the smallest y value to the largest y value possible in this graph. So it kind of looks like the smallest y value is going to be -3, and the largest y value, as I'm scanning here, is going to be +4. All y values will exist somewhere between -3 and 4 as we travel along this function. So I would say that the range is the collection of y values that are an element of the list from -3 to +4 inclusive, because again the y value could exist at -3 and it could exist at +4 and anything in between. If we were to use set notation, then our domain and range would look something like this. For I and j, we are being asked for the X-intercepts and the Y-intercepts. Those are easy to spot when we're looking at a graph. Of course, the X-intercept would be any position along the x-axis that the graph touches. So here we have our X-intercepts, and we only have one Y-intercept. In fact, if the graph represents a function, then there can only be one Y-intercept. And when you report your answers, it is a good idea to label as much as you can. Notice I labeled X-intercept and Y-intercept at the beginning of each of these results, and I did that so that we don't accidentally get confused with some of these answers that are back here. If we were talking about an interval of numbers, Sometimes we'll use parentheses on either end of a pair of numbers, and I don't want this notation to be confused with this notation down here, a point versus an interval. For questions K and L, we're being asked about the intersection of existing lines. And let's remind ourselves that the equation y equals 1/2 represents a horizontal line through the y value of 1/2. So this line here would be a pretty good representation of y equals 1/2. And if we understand that that's what we're looking for, then we can look for those points of intersection. And we have 1, 2, 3 of those. For the equation x equals 5, that's going to be a vertical line through 5 on the x-axis. And that's going to look something like this. The number of intersections this time is exactly 1. Now those two questions really do a nice job of preparing us for questions like M and N. For what values of x does f of x equal 3, and for what values of x does f of x equal -2? Now here again, we're sort of asking ourselves, when does y equal 3, and when does y equal -2? This f of x notation represents our y coordinates. Well, if we think of these questions as y equals 3 and y equals 2, then you can imagine that horizontal line again at 3 and at -2. At f of x equals 3 or at y equals 3, there are two positions where the function is equal to 3, and that occurs at these two spots, and the x values associated with them are 0 and 4. For an f of x value of -2, we're looking at this horizontal line. When f of x equals -2, well, in this particular graph, that occurs twice again, here and here, and the x values associated with them are -5 and +8. And here again, since we have multiple answers for each question, we can group them with these braces. The alternative, of course, would be to list each of these x values separate, and you can imagine how tedious this would be if we had lots and lots of answers to provide. In this case, with 2 of them, not too bad to write these answers separately, but if there were 10 results for each, we would most definitely want to use this new notation over here on the left, where we group everything separated by commas inside of braces. To finish this video, I'd like to take a look at the 3 problems that are in the top right of this group here. And I'm going to ask that you pause the video and try to answer these 3 questions on your own. Determine whether each graph is that of a function, and if it is, go ahead and find the domain and range and list all intercepts, x's and y-intercepts. If it's not a function, then tell me neither and move on. Pause the video now and resume playback in a moment to check your work. For part number 1, we would say that yes, this is a function, and by the way, if you forgot how to test for functions, there are a couple different ways. The most common method is to consider the vertical line test. So within the domain of this particular graph, does this pass the vertical line test? And we would say yes. There's no vertical line that intersects the graph that touches the graph more than one time. So yes, this is a function. As far as the domain goes, we would say the domain is all x values from -π to +π on the x-axis, inclusive. And for our range, we would say the y values from -1 to +1, because along this graph there are no y values that are smaller than -1 or larger than +1. As far as the x-intercepts go, -π 0, 0, 0, and π0. You'll notice that all x-intercepts, not only here but in all cases, all x-intercepts contain a y value of 0. And for a y-intercept, well, the y-intercept happens to be here where there was an x-intercept, which is fine. But all y-intercepts will contain an x value equal to 0. And that's true for all X and Y intercepts. For part 2, we can't really answer these questions, or we won't answer these questions because part number 2 is not a function. It fails the vertical line test. Here, for example, a vertical line would strike the graph 2 times. So it's not necessarily a function, it doesn't follow all of the guidelines to make this a function, but it is a relation or a relationship of numbers, and there are equations that can be used to represent this graph, but since they're not a function, we're not going to pay much attention to it in this particular unit. And this last graph is kind of interesting because it's got an arrow drawn at the end here. Now this arrow tail really implies that the graph is going to continue in this direction infinitely. So it goes on and on forever. So when we talk about the domain of this function and we try to identify the x values associated with it, we would say that the x values exist from here, -3, which is our starting point. We can tell that by this dot. But the x values are going to continue on infinitely as far along this x-axis as we can imagine. There's no stopping point to this graph, and so if I were to consider some x value way out here on the right-hand side, well, if I were to look up high enough, if I had the ability to do so, I would reconnect with the graph. So we would say that the x values continue from -3 up to infinity. Now we'll never actually reach infinity, so we're going to use this rounded grouping symbol here instead of a squared bracket. Similarly, for our y values, we're talking about the smallest y value being 0. There are no y values less than that. And the y values, too, would increase infinitely as much. There's no stopping point here because all y values would be represented by this graph at some point as we continue moving along this tail. Now again, I like to use the interval notation because that's what we're going to be seeing mostly in calculus. But you might be asked to report this in set notation as well, and we would say something like this. X values are greater than or equal to -3, y values are greater than or equal to 0. And that would be a fine way to represent domain and range as well. For our x-intercepts, again, we're looking at positions where the y value is equal to 0, so we have these 2 positions. And for our y-intercept, we're looking for the spots where our x values are 0. And they only occur in these 3 positions: x-intercepts and y-intercepts. I know this video was quite lengthy. I hope that helped with our discussion here and reminding you of different notation components of functions. And if you didn't need to watch the whole video, I'm perfectly fine with you jumping ahead or skipping around. And that's true for any video that I create for this particular unit. If you have more questions on this set of problems, please let me know. You can send me a message through Schoology, an email, or ask me in class when I see you next time. Thanks for watching.